Embedded system is a system designed to perform a specific task with minimal or no human intervention. Let us consider we have a car. In that, we have the meter, instrument cluster module. It displays speed in the speedo dial and then tacho in tacho dial. Whenever there is a warning, the warnings are appear in that display. Right? If there is a fault, it glows the telltales. Right. Do you believe is it a computer? Do you agree with that? It is also displaying how much distance that you traveled, everything. Shall I tell instrument cluster module is a mini microcomputer? Can I say like that? Is it a right word to use? Come on.
Yes.
No, sir, it's application specific.
Yes, I can use the word instrument cluster module is a microcomputer. Generically, I can say that because it can do the computations. It does the computations. That's why it is adding the Vodo values and display the trip computers, and it receives the information from different sensor. If there is a fault, it makes the decisions to display the warning. If there is a change in the speed, it make the deflections in the speedo gauge. Do you believe how these things are happening do you know how these things happens? When there is a change in the speed, there is a deflection in the dial. How that happens? Can you give some idea? What is your thought on that? See, I said that instrument cluster is a microcomputer. I can call that as a microcomputer with limited resource. It doesn't have a keypad. It doesn't have a OS. It doesn't have a web server. Those sort of things are there. Even after all these limitation, I can call this as a computer. It can perform the computation. It can make the decisions. Any system which has this ability can be called as a computer. That is the one thing that we clarified. Now, the next question is how instrument cluster making a deflections in the speedo gauge. How that happens? Any prior knowledge that you have about how these speedo gauges and tacho gauges are working in instrument cluster? Do you have such idea before? Any knowledge about that?
The controller fetches the data from the external sensors,
Okay.
which will fetch the data, and the controller, which is responsible to provide the speed related data to the instrument cluster,
Okay.
it will process those things and it will display in the cluster.
If it is a digital speed display, that's fine. If it is a analog display, usually every car has analog display only, right? No, deflections. How they used to do?
I think for those they will be using ADC.
No, ADC is for digitization.
Okay.
Here we are producing an output only, no?
Yeah.
Can you repeat once again, sir?
See, the question is, we have instrument cluster in car. In modern car, every car has that one. A meter which shows the speed, and then engine RPM, tacho. We do have engine temperature, fuel level like that. How these modules are showing or creating a deflections in the gauge using a microcontroller. If there is no microcontroller, yes, we can do that via analog gauges using instrumentation. But modern cars doesn't have the analog gauges. They are digital actually. Digital means they produce the deflections using some sort of motors. Do you have such idea what they are using, how that deflection happens, everything?
Yes, sir. I believe from my understanding, like they may be using servo motors, which can create the specific angle whenever the speed information is received.
Yeah, they are not, it is servo, it is stepper motor. There is a stepper motor which can make the deflections. Small stepper motor is used in for every gauge. These motors are interfaced with microcontroller using a peripheral interface. Peripheral interface or IO interface. Like that, they can interface them with the microcontroller. The microcontroller can provide a control signals based on the speed value that it received via sensors. Using speed sensor, whatever the speed value that it receives, no, it will convert that speed values to angle of deflections. These stepper motor used to have a data sheet. What is the PWM? How you can provide a control signal to them? If you want to make a deflections of 0, what is the PWM frequency? If it is 30, what is the PWM frequency? Like that, they used to specify. Right? Now, the embedded developer who develop the program for speedo gauge will convert the input speed to required PWM frequency by the stepper motor. Right? Whenever there is a change in the speed, there will be a change in the PWM generated by the controller that is fed to stepper motor as a control signal. The stepper motor will produce a deflection movements according to that. That's how it works. Similar way, how that this LCDs are interfaced, they have again IO interfacing. There are many ways to interface them, right? We can interface a LCD through for which you can send the signals, required data signals to that. That is, again, you have to study a data sheet of that particular LCD or TFT display. According to that, the controller should generate the input. When such inputs are generated and fed to display, then it will display the text message that you want to display. Similarly, these telltales are nothing but LEDs glown behind an annunciator. Behind an image, they will glow the LEDs of different colors. Right now, these LEDs are controlled via port IO. Right. Via port IO, we can configure them as an output pins. When we want to glow that particular LED, we can set that pin to 1 or 0. That will make the LED to glow, which will make the annunciator to glow so that the driver can see the telltale. Right. It doesn't happen just like that. Behind everything, there is a program. These programs are written in embedded C only. Embedded C are assembly. Actually, they can write them in the machine language directly to process zeros and ones. That is very hard to remember zeros and ones. That's why the peoples are using this assembly programming or embedded C program. Got it now. So from this, we conclude that our instrument cluster is an embedded system. It is a microcontroller. It is a mini computer. Right. You can, if it is a computer that doesn't have a keypad, it doesn't have a monitor, it doesn't have a mouse, it doesn't need those things to work, to achieve the task that it has to do. It need a minimal resources because his tasks are limited. What it is going to do, it is going to make a deflection when there is a speed or engine RPM or a fuel level or engine temperature. It is going to display some text messages in the screen when there is a warning. It is, if there is a fault, it is going to glow a telltale. These are the tasks. It is not going to display a web content. It is not going to store some data of some 1,000 students, something like that. So here, the resources required to perform the task are limited. Because of that, we are not using these intermediary layers. We are directly controlling those hardware required for that particular task using our machine instructions. To generate those machine instructions, we need certain programming language. We choose C for that one. Why we choose C, that we will study in detail later. But this is the reason. You got it now. Do you understand the concept of embedded system now, what it is, and why they call it as an embedded system?
Yes, sir.
Yes, sir.
Right.